Hey everyone, ready for another deep dive?
Always.
Today, we're going to be looking at some really cool AI audio research.
Yeah.
Basically, it's about compressing audio in a whole new way.
Right.
And it could change how we listen to music, make calls, even how we interact with AI.
Uh-huh.
Have you ever been on like a video call and the audio is just terrible?
Oh, all the time.
Super choppy,
Yeah.
or like wished your music streaming used less data but didn't sound worse?
Yep.
Well, this might be the answer.
Yeah, that's right.
So tell me a little bit more about this research.
Okay, well, it's all about how we can use a specific type of AI model called a transformer
Okay.
to build a better speech codec.
Now remind me, what is a codec again?
So codecs are basically the algorithms that take audio files
Uh-huh.
and squeeze them down, make them smaller.
Okay, yeah.
So we can stream them easily, store them.
So we're basically using AI to make audio compression even better.
Exactly.
I am very interested to learn more about this.
Yeah, it's pretty cool stuff.
So, I mean, traditional codecs, they do an okay job, right?
They do. They do a pretty good job.
But sometimes, the audio can sound a little, I don't know, artificial.
Yeah, a little bit fake.
Yeah. And this research, it's trying to get us, like, perfect audio quality, even at super low data rates.
Yeah, they're talking like 400 or 700 bits per second.
Wow, that is tiny.
It's really small.
How do they even do that?
That's where the transformers come in.
Yeah.
You might have heard about them. They're making big waves in other areas of AI,
Yeah.
like in language processing. And, they're showing that they're amazing at understanding audio, too.
Oh, wow.
They're like, I don't know how to explain it. They're like pattern recognition machines on steroids.
Okay.
They can figure out like what's important in a sound, the most important parts,
Okay.
and represent them in a super efficient way.
So it's not just about like blindly squeezing the data, it's about understanding it.
Exactly.
Wow, that's really impressive.
What's even more surprising is that the researchers found that,
Bigger transformer models are actually more efficient for this.
really? Yeah, so you would think that a smaller model would be better at compressing,
Yeah.
right?
You would think, yeah.
But it turns out that these larger models can learn so much more about the nuances of sound
Hmm?
that they end up doing a better job without sacrificing quality.
So it's almost like they're like these audio experts with like incredible ears for detail.
Yeah, exactly. Exactly.
Okay, I'm loving this,
Good.
but I do have one question. How do they actually compress the sound?
Right.
I've heard of something called vector quantization. Is that what's happening here?
So vector quantization, or VQ, is a pretty common method.
Okay.
Imagine you're creating like a giant library of sound snippets.
Okay.
It's like Lego bricks for audio,
I like that. Yeah.
VQ takes the sound and basically represents it as a sequence of these bricks
Okay.
from the library.
Gotcha.
But this paper introduces a new technique.
Okay.
It's called finite scalar quantization,
Finite scalar quantization.
or we'll call it FSQ.
FSQ. Okay. I have a feeling this is where things get a little complicated.
A little bit, maybe, but I think I can explain it.
Please.
Okay, so imagine you're packing a suitcase, right?
Yeah,
And you want to fit as much in as possible
Right.
without wasting any space.
of course. Who doesn't?
So FSQ is like a super efficient packing algorithm, but for audio,
Okay.
it takes the compressed representation that the transformer created, which is kind of like a secret code for the audio, and then it quantizes it. Basically, it makes the most of every single bit of data.
So they found a way to pack all of the important sound information into a teeny tiny digital suitcase.
Pretty much.
That's pretty genius.
And the results are amazing.
Okay, tell me more.
This new transformer-based codec with the FSQ,
Yeah.
it's doing better than the existing methods.
Really?
Not just in, the numbers, but also when real people listen and compare.
So it actually sounds better too.
It does. It actually sounds better. And get this, it even beats some codecs that use way more data for training.
No way.
Yeah, this thing is an overachiever.
I am officially hooked.
Good.
But I do have one more question.
Okay, shoot.
All this research, it's focused on English speech, right?
That's right.
So what about other languages?
Okay.
Would it work for, say, Mandarin or Spanish?
That's a great question.
Yeah,
And, you'd think it might struggle, right?
I would think so, yeah.
But surprisingly, when they tested it on other languages, it worked remarkably well.
Really?
Yeah.
Wow, so it's not just an English speech codec.
It seems like it's learned something more fundamental.
It's like it's tapped into some, like, principle of how humans make sounds, regardless of the language.
That's what the findings suggest.
That's incredible.
Yeah.
So we've got incredible quality, tiny file sizes.
Right?
this all sounds too good to be true.
Yeah.
Is there a catch?
There's always room for improvement,
Yeah.
you know? The researchers did point out that they trained their model on a fairly limited set of English speech data. So imagine what it could do with, a much larger, more diverse data set.
Right.
Think about all the languages and the types of audio out there.
So this is just the beginning.
I think so, yeah.
Like, we're just starting to see what transformers can do for audio.
Absolutely. And that brings us to an even more fascinating aspect of this research.
Oh, don't leave me hanging. What is it?
Well, they found that this transformer,
Yeah.
it can be used to generate a continuous representation of the sound.
Wait, what do you mean continuous?
So, like, without any quantization at all.
Okay, back up for a second. You're saying that this AI model, it can, like, capture the essence of a sound in a pure, unbroken form.
Yeah, exactly.
Without needing to break it down into chunks.
That's right.
Whoa.
It's pretty wild.
What are the implications of that?
So this opens up a whole new world of possibilities for what we call generative AI. AI that can create new things, not just analyze existing ones.
Generative AI for audio.
Yeah.
Now we're talking science fiction.
Right.
Like, what could that even sound like?
Well, imagine AI that can compose music that's never been heard before.
Okay.
Or create like hyper-realistic sound effects for movies.
Yeah.
Video games, or even generate personalized soundscapes that, adapt to your mood.
Wow.
We're talking about AI that understands the building blocks of sound and can manipulate them with incredible precision.
So instead of just like stitching together snippets of existing audio,
Right.
this AI could be composing symphonies from scratch.
Exactly.
That's incredible.
It's like giving AI the tools to become like a true artist.
Yeah.
A composer, a master of sound.
Okay, I'm starting to get this, but give me an example.
Sure. Imagine being able to isolate and adjust specific elements of a song.
Oh.
Like turning up the vocals or changing the tempo without having to re-record anything.
Wow.
Or picture being able to remove unwanted noise from a record.
Oh, yeah.
Or even restore damaged audio to its original glory.
That's like Photoshop, but for sound.
Exactly.
The possibilities are endless.
And think about the accessibility implication.
Oh, right.
AI could create personalized audio experiences for people with hearing impairments.
Yeah.
Or translate speech in real time.
Wow.
Breaking down language barriers, connecting people across cultures.
This is mind-blowing, seriously.
Pretty amazing stuff.
So let's zoom out for a second.
Okay.
What are the big takeaways for our listeners?
I think the biggest one is just the sheer power of transformers in audio processing.
Yeah.
They're not just for language anymore.
Right.
They're proving to be incredibly versatile, capable of tackling these complex audio tasks
Okay.
with amazing efficiency.
Yeah, I'm with you.
And second, this discovery that these transformers can generate a continuous representation of sound. That's a major breakthrough.
Yeah.
It points towards a future where AI can not only understand and compress audio,
but also create and manipulate it in ways we never thought possible.
So we're not just talking about better audio quality here.
Right.
We're talking about like a fundamental shift in how we think about audio.
Exactly.
And the role of AI in shaping the soundscape.
Yeah, it's like we're entering a new era of audio.
Okay.
Where the lines between human creativity and artificial intelligence are becoming increasingly blurred.
That's both exciting and a little daunting, isn't it?
It is.
This technology, it could change everything.
Yeah.
How we listen to music, how we communicate with each other.
It really could.
But it also leaves me with a big question.
Oh.
What's that?
So, if this AI can understand sounds so deeply, does that mean it's like tapping into some hidden language of sound?
Oh, that's a really interesting question.
Like, is there a secret code?
Yeah.
A fundamental structure to like all the sounds we hear.
Right.
From birdsong to Beethoven.
It really makes you think, doesn't it?
It does.
About the nature of sound and how we perceive it.
This research, I think it suggests there might be these underlying pattern structures that we're just beginning to understand.
It's like we're cracking the code of the sonic universe.
I like that.
And AI is helping us do it.
Yeah.
What are the implications of that?
Well, I mean, the possibilities are pretty mind-boggling.
Okay, like what?
Imagine AI that could help us create music.
Yeah.
That resonates with us on like a deeper level.
Like,
or design soundscapes that evoke specific emotions or memories,
Yeah.
We could even see new forms of music and audio emerging that we can't even conceive of right now.
It's like opening a door to a whole new world of sonic experiences.
Exactly.
It's exciting, but also a little intimidating.
Yeah, I get that.
Like, what does it mean for human composers and musicians
Right.
if AI can create music that's potentially just as good
Yeah, that's a valid concern.
or even better?
And it's something we'll definitely need to grapple with
Yeah,
as AI gets more sophisticated.
for sure.
But I think it's important to remember that AI is a tool.
Okay.
It's up to us to decide how we use it.
So instead of seeing AI as a threat,
Uh-huh.
we could view it as a collaborator,
Exactly.
a partner in pushing the boundaries of musical creativity.
I like that a lot.
This has been an incredible journey,
It has.
from tiny data packets to the language of sound itself.
Right.
This research has really stretched my imagination.
Me too.
Any final thoughts for our listeners?
I think the biggest takeaway is that we're on the cusp of a sonic revolution.
Okay.
AI is changing how we understand, create, and experience sound.
Yeah.
And the future is full of possibilities.
I love that.
Keep an open mind, keep listening, and who knows what sonic adventures await.
Couldn't have said it better myself.
Thanks for having me.
Thanks for joining us on this deep dive into the world of AI audio.
Of course.
Until next time, keep exploring the amazing world of sound.